Hey guys, in this lesson we are going to learn to solve quadratic equations by factoring. So taking a look at number one, there's something I need to emphasize right here at the beginning. Now in previous lessons we have learned to factor quadratic trinomials. So the directions would say factor or factor completely. And we saw problems just like problem number one here, where we have x squared minus, I forgot what it was, x squared minus x minus 30. Okay, and now we're seeing something that's almost the same, but the directions say solve. And instead of just having x squared minus x minus 30, now we have x squared minus x minus 30 equals 0. Now, when we were factoring, we went like this. We said, okay, binomial times a binomial, x squared, that will be x times x. And then we looked at the 30, and we would think 30, that might be 5 times 10. Now why did I put 16? And did I really say 5 times 10? That might be 5 times 6, or it might be 3 times 10, or it could be 2 times 15, or it could be 1 times 30. So we would decide which one of these pairs we were going to use to factor 30. Now, keeping in mind that the inner plus the outer must equal the middle, I would look for which one of these pairs can help me get -1. And so with that in mind, I'm liking the 5 times 6 option, because 6 minus 5 is 1. So let's do that. Okay, so 5 times 6. Inner, we had 5x. Outer, we had 6x. If we're going to get a -1, we need a positive 5x and a negative 6x. So there's my positive 5x, and there will be negative 6x. And when the directions were to factor, then we were finished. We just factored. So we could put a box around this, because this was the final answer. Okay, now this problem is similar, but you can see it's slightly different. We have this equation now. This was not an equation. We just factored and we stopped, and that was it. Now when we're solving by factoring, so we're still going to start off the same way. Alright, we're going to factor this, and as you just saw, it's going to be x plus 5 times x minus 6. But we don't stop there. That's just factoring. Solving is like finding x, or whatever the variable is. Okay, so we need to go all the way until we get x equals something. So the way we do that is we pick up from here, and we set these factors equal to 0. Okay, so either x plus 5 might equal 0, or x minus 6 could equal 0. And we'll solve these. So subtracting 5 from both sides will give us x equals -5. So that's one solution. And adding 6 to both sides will give us x equals +6. Okay, so these are the solutions. Now I really wanted to emphasize these side by side, because every year when I teach this concept, the test comes, and on the test we will have problems that just say factor, and we'll have other problems that look like this and they say solve. But I'll have several kids in each class on a problem that says solve, and there's an equation, an equal sign, students will just factor and stop right here. And then on other problems where the directions will say factor and there's no equation, no equal sign, I'll have students factor correctly. But then they'll keep going and they'll go, okay, and then x plus 5 equals 0, and x minus 6 equals 0, x equals negative 5, x equals 6. They'll try to do this on a factoring problem. So I really need to emphasize this to you. Every year I hope that this will be the year that I don't have 5 kids do that. So please understand, if the directions say factor, you're not going to see an equal sign. Okay, it's not an equation. We can't solve it. We just factor and stop. If the directions say solve, even if you didn't read the directions, if you see that it's an equation, an equal sign involved, then it's going to be solving, and you're going to factor, but don't stop there. Set those factors equal to 0 and solve them until you get x equals something, x equals something. Okay, 2 solutions. Alright, number 2. The first step of factoring is to look for a GCF. You quickly see that this problem has no common factor, so we go ahead and factor as a binomial times a binomial. X squared has to be x times x. 27. The first thing that comes to mind when I see 27 is 3 times 9. Okay, so let's try that. So 3 times 9. Inner plus outer equals middle. Inner, I have 3x. Outer, I have 9x. The middle that I'm talking about is this negative 12x. I can make negative 12 out of this if both of these are negative. Negative 3x and negative 9x make negative 12x. So that would, wait, did they really write plus negative 12x? Alright, I'm going to have to change that. Anyway, that means both of these would have to be negative. We always need to check one more thing, make sure we're getting a positive 27 here. Well, a negative times a negative is a positive 27, so that's great. Alright, I'm going to move this out of the way now though. So, because this says this is an equation, I need to solve it. So, I'm not going to just stop here. Oh no, I'm solving. Hold on, this is bugging me. Alright, never put plus minus, guys. Plus a negative number is just subtraction, so just do that. Anyway, so we need to set these factors equal to 0. So x minus 3 equals 0, x minus 9 equals 0. We're going to get 2 solutions out of this. In general, the degree tells you how many solutions you will have. Okay, if you count repeated solutions, because sometimes you'll get like x equals 3, x equals 3. If you count that as 2 solutions, you know, when really it's just 1. But if you were to count things like that as 2 solutions, then the degree always tells you how many solutions you will have. So we are expecting 2 solutions. Adding 3 to both sides, don't you know? We're going to get x equals 3. Okay. Let's just pretend nobody saw that, so I don't have to edit the video. Alright, x equals 9. So these are our 2 solutions. By the way, let's make a quick connection. Let's look at the graph of the equation. I feel like changing colors. Let's look at the graph of the equation y equals x squared minus 12x plus 27 real quick. Okay, so we got x squared minus 12x plus 27. Alright, let's take a look at the graph of this thing. Okay, so it's quadratic, you know, x squared, so we knew it was going to be some type of a parabola. But what I need you to notice is the significance of these solutions. So we got x equals 3 and x equals 9. Turns out that those are the zeros or the x-intercepts of this parabola. So you see that the 3, 1, 2, 3 right here, and then this x-intercept, this crosses the x-axis at 9. So these are the zeros of the function. So I just want you to understand that. Okay, back to solving though. So number 3. So accelerating the process a little bit now that you get the idea. X squared will be x times x. 6. It's either going to be 2 times 3 or 1 times 6. Let's try the 2 times 3 first. Alright, got another plus negative bugging me. Inner we have 2x, outer we have 3x. We can get a negative 5 out of this if both of these are negative. So that would make both of these negative. Will that give us a positive 6? Yes, negative times a negative is a positive. Alright, but we don't stop here. Oh no! This is a solve problem. This is an equation. See that equal sign? That lets you know you need to keep going until you get x equals something. And we will get that by setting these equal to 0. So x minus 2 equals 0, and x minus 3 equals 0. Okay, adding 2 to both sides gives me x equals 2. Adding 3 to both sides gives me x equals 3. Okay, and again, if I were to graph the parabola y equals x squared minus 5x plus 6, these would be the zeros of this parabola, right? We would see that it would cross the x-axis at 2 and at 3. Okay, that's what that means. Alright, I'm not going to do that anymore because that's time consuming and we got a lot of problems to do. Number 4. Oh wait, whoa. Okay, this doesn't have 0 on one side. Alright, in order to solve like we're doing, we're using something called the zero product property. Alright, we've been using this. If I know that a times b equals 0, I don't know what a is and I don't know what b is, but I know something. At least one of these has to be 0. That's the only way they're going to multiply. That's a terrible b, I just noticed. It's an awful b. Maybe this is, if I had 0 times b, that would make 0. Or, so maybe a is 0. Or, if I had a times 0, that would make 0. Or they could both be 0. So this is what I've been doing. If I have two things multiplied together that equal 0, either maybe a is 0 or maybe b is 0. Okay, we could get solutions either way. So in this case, this was like my a and this was like my b, and so I set them equal to 0 like this and this. Alright, but this only works if we have something times something equals 0. Okay, we can't do anything like that if it equals 5. We can't say, oh, this equals 5 and this equals 5. No, it has to be 0. So let's get 0 on one side by subtracting 5 from both sides. So if you do that, then I will have n squared plus 7n plus 10 equals 0. Okay, and then you can go ahead and factor it from there. So this will be n times n, and 10 It's probably 2 times 5. Let's go with that. Could be 10 times 1. Inner, that gives me 2n. Outer, I have 5n. I can get 7n out of this if they're both positive. That would mean these are both positive. Okay, so I factored it, but I don't stop. Okay, I set these factors now equal to 0. Now that I have equal 0, I can use my zero product property. Okay, minus 2 gives me n equals -2. And minus 5 gives me n equals -5. Okay, alright, I'm going to stop this video here because it's about that time. But I will continue on the part 2 with number 5.